Good morning, everyone. It's an honor to be at Open University and privileged to listen to one of the world leaders in tall buildings. In fact, the lecture that he came and delivered in the course that 25 years made me able to design tall buildings. Actually, if he didn't come and deliver the lecture, I think my designing of tall building will be little bit delayed. So it's a great privilege to work with him on many tall buildings in Sri Lanka. I would start with a question, Professor. Like concrete technology has grown from, those days when we were designing the celestial residencies, it was like grade 50 that we used for as the highest. It was also very difficult. Thanks to the people like Ravi with new admixtures, we could have even now reached 85. Now you are talking about grade 150.
Correct.
Can you advise us whether it is safe to use very high strength concrete in tall buildings?
I think it's a very good question, Sharamal, because again that why we can design all these tall buildings is because of the high strength concrete. Other way around, otherwise I don't think we would have had all these very tall buildings. So coming up with from the beginning, again actually even the researchers are, I have to say that as academic we all have to take some responsibilities there, where we have wasted time as well trying to improve the paste, and saying that we can get like now very high strength concretes. I'll come to that, but there's way of doing it. But then because it breaks through the aggregates, as I mentioned. So the latest one of the PhD projects that I finished about 2 years back, one of my students, was just to look at the aggregates. So Sri Lanka, my understanding is, you will know better than me, again as it's very good audience here, Sri Lankan aggregates are not too bad. But there are problems around the world. Dubai had to import the aggregates. Malaysia now, you also know in Dubai, they were talking about not achieving the high strength concretes in Malaysia. So there are some issues like that. But so we need to improve that. Other change which really had the world, we could see the evolving the change. Again, the last keynote that I gave about 2 weeks back in Mumbai, I was really privileged in the audience had Professor Malhotra, who he introduced fly ash to the world through the CanMet and from Canada. Of course, his origin from India. I had a photo with him, and he was sitting in the audience. I told him when I was talking. And so people like them have introduced fly ash to the world and to make it sustainable. So the privileged pozzolanic admixtures at that time was thought like, it'll just come and go, and then it improved the durabilities and many other things. And you're one of the pioneers here to have used the fly ashes. And now then it changed everything, and we got the admixtures coming in. Again, Ravi, you work on with Millennium. Have allowed that to be used. Then we had the manufactured sand coming in, and you need to have used special admixtures for that. And like that's what's happening in Sri Lanka. So it's evolved a lot, but one caution is that we used to, those days, whenever we know that if we ask for 60 MPa concrete, we would get 80 MPa concrete. But it's the other way around now. We are finding even in Australia, they are asking for 140 MPa, you don't get the 140 because it's a special type of concrete. So 120. So there's a danger of people saying, even the marketing issue, not here, Australia, sometimes some people go and say, yeah, we can provide. It's really not in the lab. We can lab very easy to produce. Lab, no, it's no problem. But when it's a commercial, commercially producing that, so there are some dangers like that. So design changes, I'll be very brief with this answer. I mentioned that confinement. So as designers, we can work backwards and get the best performance to make it ductile. So we can even use some steel fibers if you want to do that. Now coming back to the, when I say aggregates, again that some pioneering work we had done with the reactive powder concrete, which is 220 MPa. Now I'm allowed to say that at that time, about 10 years back, when the security concerns were there, we managed to, I had a PhD student who finished, and then we did reactive powder concrete, we take the aggregates out. So we can do some basic things, but it becomes expensive. So take the large aggregates out, then obviously we are taking the weak surfaces out. So that is 200, you can even go to heated curing, you can go to 400s. So you can go anywhere, but you have to be very careful. Also the cost is a factor. So my message also, as academic I had to pass this message, we had to know, we can't forget about the fundamentals. So we had to really go back to the fundamentals, look at the performance and work backwards to get the best material. I think it's a very good question you're asking, because there are dangers. Yes, people are blindly using it and getting it wrong. And there was a failure of a column even at that time in North America, because of the strength unusually dropped with time. We know concrete basic is the concrete strength increases. We say increased by about 15% in 1 year. So thank you for reminding me. Now we are in a different world using different materials for concrete now. It's a totally different concrete. So we can't just say the concrete strength is increasing, because we are using fly ashes and we are using some materials to really improve the workability, but then the early age strength, that's again a basic problem. So strength is not the only thing, because there were failures of post-tension failures of anchors in Australia. That's why some of the PhD work you will see in that we have done that trying to. So that is a very good question. We had to be very careful. Even the designers had to understand the fundamentals. I know you have done that in some number of projects to really understand the behavior and then design that particular mix. We can't just leave it to the concrete producers and just leave it and say, right, we can use it in the building. So we need to be involved from day one.
This concrete grade we normally specify based on 28 days strength.
Correct.
But there were questions like for raft or columns, we can consider like 90 days or 150 days strength, because you don't need that strength at that moment. So therefore you can reduce the cost of the concrete.
I think it's a very good point, because exactly what you said, because the performance required is after a few weeks. But same time other way around as well. As I said, the early age strength. So we can't just leave it to 28 days, because it's different type of concretes we're using, because we know we're using fly ashes and all that, that early age strength development is less. So we had to ask for the 7-day strength rather than the 28 days strength if you have the post-tensioning after a few days. So exactly what you said, working back from what is required from the material and design the material.
Thank you, Professor.
Okay, Professor. So I think for me also great honor to be in the audience, and also I am listening to the performance-based design what you have done. So I have some of the experience in the Euro, right? So they are the persons who introduced through the Eurocode, especially Eurocode 2 and the Eurocode 7. So I have seen some of your work also on the ductility. So the challenge, the previous comments that the Shiromal also telling that, so we go for the high strength concrete, but do we really monitor the performance of this concrete? So that's because in the site condition probably you go with the workability and the slump condition. So how do you assure the quality before concreting? So that is the big challenge in the future, the contractors and also the admixtures people. So all these people have to face.
Yes, I think it's very, very important. Thank you for asking that question. Today I didn't spend too much time, but what's I think very, very important question, because to know the actual quality. Now we go to the doctor and we do this MRI test and all that sometimes, but same way it's a big area for the future is to know the actual performance of the particular structure. So things like non-destructive testing, we have to really make sure after it's constructed. I'll give one example because it's a very important one that I had some involvement. The non-destructive testing is a key for the future, because we are going to have some aging structures even here. Structures are aging, and we have some rehabilitation, maintenance will be a key for the future. One other thing, we had a Q&A session. So this time Q&A, I was the one who was asked to really be part of the, people are just asking, firing questions. I had to answer in concrete in Melbourne. It happened. And one of the precast manufacturers came and said, we are going away from precast. I just said that in 10 years time we will be all having precast. His problem is that he is putting precast columns, and underneath when you have the grout, he does not know the performance of the grout.
Yes.
So, because you go and grout it, how do you know whether you have the full grout everywhere? So, he said he is getting now really worried, and I need to look at this failure in Australia. What happened was, my understanding is that I need to be there to looking at it, but is that there is some spoiling of the elements. So, we are making some, so it is really the grout. Only way to check is that we got this I had that equipment in the Melbourne Uni. We have this UPV, ultrasonic pulse velocity type of equipment to really check the status of the grout. But you can't afford to, one side we are going and saying, going and produce columns in the factory and bring it and precast and put it on top of the slab. Then if you don't know the quality of the grout, how do you know that? So this is a very, very important point you mentioned. I think the really looking at that the health side with structural health monitoring, which is a really another growing area, and to really know and then also using performance based techniques, as you said, we have the computers now. So we can look at the full performance, and I know some of that work you have done for buildings here using performance based for seismic. Now, but it's really like that to know the actual performance of the structure. It's a very good question. It's a key one for the future.
We have a good audience here with a lot of experience. I would like to ask the audience to raise some questions. Anybody?
Concrete, high strength concrete, we have problems because we are not sure of the performance of almost all materials, in the sense when it comes to concrete main products like it's okay or? Yeah. All products like concrete, you have coarse aggregate, you have fine aggregates. The coarse aggregate can be also, fine aggregate can be manufactured sand or river sand. Then you have the admixtures. Then you have cement and fly ash or silica fume or whatever. Then the consistency of this, quality of these products are not assured. Now recently we have had a lot of tests in certain what you call high strength concrete grade 60 and 70, where the 7-day strength has not increased. The 7-day strength was 65, but it ended up at 70 after 28 days and after 60 days. So there are problems with the cement. There are also problems with the aggregate because with the source, we are not sure of the source. So suppliers can change the source. And then we think that the sand is, fine aggregate is the same, but it's not the same. Sometimes it is these excavators from sand dunes and then not properly washed. Sometimes it can be sand from the river, from the sea, but not properly washed and things like that. So the contractors or the manufacturers or concrete producers has to run a big risk, and therefore the entire designer's expectations will not be fulfilled. There's a great danger. And we have, I think I had to have a close chat with Mr. Shrimal. We have serious problems because we are not sure of the products.
Correct.
In spite of ISO and all these certifications and all that, we are not assured of quality. That
Generally, what we
issues.
do is like if you want 70, we target 90. Otherwise, as you said, there's a huge
there
problem.
is a very interesting thing. Now we have used net steel for a long time for a lot of projects, and there I think the net steel passes by a very small margin because the technology is high and consistency of supervision quality management is very high. But here we need for 70 we need 90. We need a lot of resources and a lot of money.
Correct.
Because of our, we are not consistent with our
material
our supervision, quality check, and also performance.
I think it's very important if I jump in there, but it's a very important, very important question which I didn't cover. Another one which a trend, this is applicable not only to high rise, so I didn't cover too much, but the word compliance. So the word compliance will come to the world in a big way. How to maintain the and monitor it, how to police it, how to the quality of the material, and I think you brought a very important point again, that the coming into concrete. Now the problem is that I know there are some very good material suppliers here, but same time it's really danger. Even I'm not saying all the imported products are like that, but there's some danger as well, just relying on some of the imported products because of the quality. Because we have done this in Australia, there are certificates being produced. When we go and test in the lab, we don't get the same result. So because we have to rely on some certificates done, I'm not just saying the imported, but we have to rely on some certificates done in a lab. They have hand-picked some materials and then done that test. So when we apply to the site, there's a big danger. So I think it's a very good question, Captain. Thanks for asking that, because I think we need to develop some techniques to really quickly to make it compliant, and also other ways. Now, again, rather than taking a lot of time, that's what happened to the La Crosse building in Australia. Why the ACP got burnt and the facade got burnt, because of they were asking for one product, and then they have substituted a cheaper one coming from overseas. There was no compliance and monitor requirements, so the builders just used that, and then the fire came. Now there's a big case coming up in a lawsuit coming, who is responsible for all that. Anyway, I'll leave it to another time. But that one. But I think you got a very good point. Now, also as researchers, we have some responsibility also. Now, there are 60 odd tests. We did a bit of a literature review, not literature, we came up with how many tests are possible for workability. And we came up with some 60 tests, 60 type of tests. So still the slump test is the best, true. Slump test works because it's practical. We can't do a lab test on site. But same time, slump test may not be the best for different type of concretes. Now we are going to self-compacting concretes, we are going to, so we are playing with the concrete. And so because of that, we can't just say slump test is the best test for the type of concrete, because I think another prediction I have made may be correct, I'm not sure. 5 years time, 10 years, we'll just only have self-compacting concrete. We will not have lot of good chemical admixtures for that to produce that. But that is really going to happen. Vibrators will go, vibrations and all that. We need all that. So that's slowly happening around the world. So it's and the quality, maintain the quality. So we can't just rely on those tests. So we have that coming back to that point. I think you raised a very important point: compliance, monitoring of the material, and also maybe there's exactly what you pointed out. When you take the core samples of a slab, it's different from the cylinder test that been given on site, the paper. It may not represent all that. That's why we have gone to some new techniques called maturity methods, and I'll leave it to another time for that discussion. But it's in the temperature monitoring, and I think we have also done here, monitoring the temperature to really put some thermocouples to really make sure the structure that you get. So we are using indirect methods to really, because obviously we can't test big samples in a real structure, but put some thermocouples and some strain gauges so that, so I think you've got a very good point, Captain. It's really something that, because the world is changing and we're going to this high expectations from the material, we need to really improve that side, what you mentioned.
One more thing, sorry. I think you are the pioneer in sustainability and Green Building Council, and you're also one of the pioneer companies. And it's very important because today, beyond this ISO and other things, we need to have some social responsibility and sustainability in a big way if the world is to sustain. Construction is to sustain. I think that, thank you for doing that. I think we have to add one thing to green building and sustainability. You have to also add social responsibility. When we produce concrete, when you supply a product, you also have to be socially responsible.
Correct.
By legally, you can't bind a person to do that because it's very intricate and very complicated.
Thank you.
I think that's very a very important point, and I had to really also acknowledge Captain Marga is a founder member of the Green Building Council. So
And he has built the tallest green
building in the world.
in the world.
One of the tallest, the Celestial. So I think one of the pioneers in that side. So we can be proud of all that, and people like you who have really not just thought about just the cost or just reduce the cost and just build something, but you thinking about all that. And I think you also brought a very important point of I think I also mentioned this, the social responsibilities. So I think again that I'm advertising this, but you are leading it. But the Sri Lanka Green Building ratings is only one having a cultural component, social and cultural component giving points. So it's one of the world first. I think others could be copying now, but So I think it's really that not just the engineers and architects had to control it, but you got a very, very important point there.
In fact, we have put some ecologists also into from this version. So you have to have an ecologist in your team so that we can look at the fauna and flora when we build something, what is going to happen to the plants, what is going to happen to the birds and the animals in that this thing is how we can bring back them to the same environment. So that is also in part of the new version of the green building
So that's really,
rating.
That's showing that the Open University is it, because Open University, not because it's invited me today to talk, but Open University has that capacity because of the multidisciplinary, the capacity that you have bringing those multidisciplinary teams, as you said. That means ecologists will become popular in the building industry because you have to have one to be involved like that. I think because Open University is training number of multidisciplinary areas are like now being covered by Open University.
Ravi?
Yes, to add a little bit from my side as well to the continuation of the discussion. As a person who has been in the mainstream construction from the beginning in early 90s, actually I can remember when we did the grade 50 concrete for the first time for the Jai Kilton Tower. And we now thought of having this fly ash. We didn't have fly ash. We used the cement, 530 kilos of cement, 0.3 water cement ratio. So that's how we did. And the next step was this Jai Kilton, the Celestial. Then we amalgamated fly ash, silica fume into that. So we came with a highly more technology-oriented mix design. And now we're talking about the high rises, the high flowability, and then the self-compacting concrete and also the manufactured sand. There are a lot of materials
Self-compacting
now.
also we first did with Marga on this highway.
Yes, that is, you are involved in and you wanted a self-compacting concrete. And I showed the video to Captain actually. we did that concrete and he was so curious, he came to see the mixed trials. I wanted to show him how we did that. So I showed him the video. That was the first time we did that. What I wanted to highlight here is the problem that we face is mainly due to not the lack of the technology. It's a inconsistency of material, especially the fine aggregate inconsistency is the main problem. Now we are transforming our admixtures also from the conventional lignosulfonates to naphthalines to now the polycarboxylic. So when it comes to the polycarboxylic, the sensitivity of the concrete is very much higher. And we wanted to see what exactly the problem was. And we see when you say the fine aggregates, the fine materials less than 0.6 millimeter is the one that causes this variation. So we don't think of this. So any fine material is fine material for us. But when you get the standards, the zone 2 curve is intact. So that is fine. But that is changing at that level. So you need to have a graph highlighted so that you can see the differences. So that is one of the things. And adding something to what Captain said was this, the sustainability. Actually, the sustainability, now we need to look at the commercial, sustainability and the technological sustainability. Now we are now at the commercial point of view now for the next 5 years, we are in a really bad situation, the Sri Lankan construction industry. So we need to find the ways and means of how we are going to be sustainable in terms of the economy.
Cost-wise.
Economy, yes. So the technical point of view, of course, we all experts are here, so they will look after that. So there will be a very good green light you see there, so we can all get together and do something better. Thank you.
From the research side,
Now we were talking about the strength of high strength concrete, the strength of the concrete, and as Professor Priyan said, the paste has been strengthened through various admixtures,
Correct.
and now the problem seems to be like with the aggregate.
Yes.
Now this coarse aggregate strength cannot. Are there any attempts which has gone on to improve the strength of the coarse aggregate, like this Smarties theory, where you can have a coat around the aggregate and strengthen the aggregate, just the simple Smartie and sugar coat like on the aggregate itself to have something. Are there any attempts on that?
This is an excellent question, because I didn't cover all that technology side today. We are looking at, the short answer is we are looking at some nanomaterials to really coat the aggregates so that you get improve the strength of the aggregates. I think the other word we are trying to use is impregnation, that is to have to strengthen the aggregate more. Anything we can do. There could be some weaknesses in the aggregates so that we can improve the performance. I think very spot on, very nice question, that one. But at the same time, then there are other problems. We know there could be some weaknesses in the aggregate paste layer, all that. So
And
it's
cost
really
and the economy of size.
exactly. But also another important point you mentioned, which I was going to comment on it. We can't just still use the traditional mixed design methods now. We are still using the British BS1. I can't remember ever.
We don't use.
Someone, Rohan, you are an expert concrete. Remember which BS code was the mixed design? I've forgotten that. But no. But what I'm trying to say is we need to change that. So we need to change the procedures we have been using. We can't just use the same procedures. As I said, slump test is very good, but maybe there are better methods. Now, mixed design. Again, I have to give a lot of credit to those who are students in the audience as well. Can look at one of the pioneers, Pierre-Claude Aitsin from Canada, which I had a chance to spend a week with him in 90s. He has a book and he explains this new way of mixed design. We can't have to go away from traditional methods. We need to go to what's called the packing density method. I won't be technical too much today. Packing density is to exactly what you said, how to pack the material and look at that performance, the permeability to the strengths and all that through that. So we had to go away from that, and that really also bringing some new technologies, as you said. Let's do something innovative. That could be, because I think you are right 100%. We may have got the maximum out of the aggregates from that. So even that we found the basalts to granites to all that in that Australian work. I think we are trying to do some work in Sri Lanka as well. But it's same to look at the aggregates and to do that. So I think you got a very good point.
Thank you very much. You answered my question.
I want to take this from concrete out of concrete to another first. So because I know after now this Neville and Kende, they are all old. I think he's the only living expert on concrete. So we had to take out of the concrete now.
I don't think I can fill their shoes. But anyway, we have learned from them. Sorry, because you brought that. I was telling Tushar on the way, this is a privilege. I missed total privilege when I met Neville once in a conference, Professor Neville. I consider him to be the, done so much. And that book is still, we can read that, still applicable. He said the last edition is still, he may come up with anyway. So he told me once in a conference in Dundee, once he said when he was there, he gave a keynote and I was a very young lecturer. He said, do you want to join me revising that book? It's a really huge opportunity I would have had to really, but at that time I thought, I can't travel all the time. You can anyway. But thank you for that, but I don't think I can even get closer, but at least,
This, now you are now current research is on modular construction.
Yes.
Especially modular tall buildings.
Yes.
which is built in like 30, 40 days.
Yes.
So what is the risk like robustness? What are the special things that the designers have to think about? Because it's a construction, during construction stability, and then the after construction stability.
And Shomal, you're well experienced and a person who really coming from you, it's that is very good. You already covered the 2 points which are really the key. We can do any modular, it's true, we can do it in factory, but the key ones, a brief answer is the connections, getting the connections right, because if we don't get the connections right, there are 2 or 3 key things which coming up is that the how to do that. You mentioned the temporary works design is another new area. They even now they have come up with the temporary works design as a separate trade. So maybe it's a key, exactly what you said. So designing the connections and to make sure the making it lightweight. We know to lift it up, we need to make it really lightweight. I'm sorry to bring back to concrete, but even lightweight concretes and other lightweight materials had to be used to do that. But other key point is that we call it the design for manufacturing and assembly. You have the opportunity there are getting together and designing from the day one how to think about how it's constructed. This is relevant to modular or any other ones to start thinking about. Now in some countries, especially in Europe, they had to give a plan to really how to dismantle the building, even how to not just to construct, they have to give a plan how to demolish and dismantle. So modular is becoming very popular because you can dismantle it quickly. But same time, I think you brought a very important point. Other one is the transportation. So we need to make some special precautions. Start thinking about before anything. People have got into trouble modular. They're doing modular. When they try to transport in a truck, they find that the bathroom area is not too far down. They can't put it to the truck. Too late. So I think you're exactly right, and there are some very key ones will come at that.
So in terms of these high-rise buildings, so the comfortability is another one we have to think about. This stability is a part of our jobs. But anyway, when it's come to, I have seen the recent publication in the Singapore that they lost 32% of the vision in the young kids, because the one key point is they are saying that the long vision is covered by the high-rise building. So I think the building syndromes in also the Sri Lanka now, the sicknesses coming and all. So what kind of approaches we should consider, especially in design of the high rises, because sometimes everyone is to have a good view, long view, etc. But when we take for example, Colombo City, so the next building coming up entirely, finish the vision. So I think we should address in a way that to have a corporate plan by the local authority or central government to have some zonations that you should be having the high rise along this line, etc. Unless we are going to face this problem. The Singapore 32% the kids get affected by the high rise. So what do you think about the future challenge on this?
I think it's a very, very important point. Today I didn't cover that side too much, but so I have to say that there's a danger, as you said, making it sustainable. All this issue of fire facades came because it's a sustainability thing. We try to make it the thermal comfort and all that and try to make the facade sustainable, brought the ACPs, now it became a fire problem. Now the one last very important point, indoor air quality and all that, I think we had to do lots of work on the lighting, all that, and I think we have forgotten that. Yes. So we need to spend more time. One last one, I have to say this one, another one which we had one of the words first here in Sri Lanka last year, Lear, looking at, he's still communicating with us on what's called dynamic architecture, which is really rotating the building.
Yes.
In the afternoon, you will have one area, yes, one vision, the environment you will see the sea side, at night you will see another one. So to rotate the building. So dynamic architecture also becoming popular. So maybe that could address some of the issues like that. But it's a long way to go. You're right. Yeah. But you brought a very important point, which really I think that we can't just we need to really bring that. We are making it sustainable, He said the IAQ, the India quality, is at the best. And we are having all these new things. What are the VOC levels of these ones? We don't know. We are, someone said that, please don't, there are fly ash people here, but one of our, like, she was working in our department, went and said, you see, this fly ash is real danger for she got all this television coverage saying fly ash is really, fly ash based concrete is not good for the health. So we don't know the answers. You're right. Maybe this big area which we need to focus on.
Yeah, going back to the Vesak lantern and the merry-go-round.
Going back to basics. Other day we were saying modular started from pyramids. And
Yeah,
also I was showing that day a slide. Lower Mahapai had precast columns. We are going and saying prefabricated, but how many years back? You mentioned this.
2005.
The 2000. So prefabricated maybe not new. Maybe it was invented in Sri Lanka. So prefabricated columns.
Matter of finding the history.
Exactly.
I think we had a good conversation with the professor and also a good lecture. Organizers are asked, I mean, although I have a lot of questions, it's not, there is no time to answer. I think definitely the audience also has a lot of questions. Thank you, Professor, for with all your busy schedule coming all the way from Australia to the Open University and addressing our staff and also the students, and we wish you all the best and thank you. Thank you very much.
So, to formally thank you, all of you, may I invite Dr. Jayantha Wattevidana to give the vote of thanks.
It is my privilege to be here to propose a formal vote of thanks. Anyway, this is the first distinguished lecture of the year 2019, organized by the Center for Educational Technology and Media in collaboration with International Relations Unit and Information Technology Unit. So first of all, I must thank on behalf of the SETMI and also on behalf of the Open University of Sri Lanka for Professor Priyan Mendis, University of Melbourne, to come over here and sharing your international experience with us. We all were fascinated to hear your long experience and also your enthusiasm to share your experience with us. Never-ending enthusiasm. And also, we have very distinguished audience today. Engineer Shiromal Fernando, session chair of the event. He is the managing director and the principal structural engineer, directors and managers of Civil and Structural Engineering Consultant Private Limited. I must be all thank you, Shiromal, for chairing this session and leading the discussion. And also, Mr. Sankar Senaviratne, head of industrial sales, INSEE Cement, and its managers, and also Mr. Ravi Nisanka, Chairman, Millennium Concrete Technologies Private Limited, for very important questions you raise. And of course, Captain M.G. Kulratne, Chairman of Maga Engineering Private Limited, our neighbor, next door neighbor. Then again, Professor Ruwan Weerasekara from the University of Moratuwa. And also, I especially thank our Vice Chancellor, Professor Ambahan Ariyadure, for allowing us to and facilitating all this to have this great event. And again, we have our Dean of the Faculty of Engineering Technology, Professor Dolagi, and also Professor Kolita Weerasekara. He, I think, from last few weeks, he visited SETMI many times to arrange all these things. And we have Professor Manoj Palliwatta, Chairman of Institute of Engineers, Sri Lanka. And we have all distinguished invitees from the university and also from the industry and some of our students. We thank all the members who participated here, and also my staff, SEDME staff. They all are working hard to capture you and all the discussions as much as possible. Once again, I thank all of you. Have a good day. Thank you.